Welcome to today's video on Cambridge IGCSE Mathematics 0607 and 0580. The topic for today is functions, where we will be focusing on the subtopic logarithms. Logarithms is basically the inverse of getting or raising something to the power of a particular number. It's the inverse of taking the exponent of a value. For example, if I say 2 raised to the power of 3, this is getting the exponent of 2, and I know this is going to be 8. Then the inverse of this would be asking the question, which number should I raise my value to get my answer of 8? And this is where logarithms come in. So if I say y is equal to 10 to the power x, then I can use logarithms to say that x should be log y to the base 10. Let's look at another example here to further solidify those concepts of logarithms. Here we can see 1,000 is 10 cubed, which is saying 1,000 is 10 times 10 times 10, which you can say is 10 cubed. Now, knowing this relationship between 1,000 and 10 to the power of 3, I can ask the question, which number should I raise 10 by to get the answer of 1,000? And how I would write this question in terms of logarithms would be log 1,000 to the base of 10 should give me which value? This is asking which number should I raise 10 by to get my answer of 1,000. And because we know the relationship between 1,000 and 10 to the power 3, I can say that the answer for this should definitely be 3. We can also use logarithms to solve questions where we are not quite sure of the relationship between our base and the power. For example, when we want to solve this equation, 10 to the power x is equals to 4.24, but we want to find out what x is. To begin this question, what we can do is we can rewrite this as saying x should be equals to the log of 4.24 to the base of 10. And we can solve this using a calculator. So what we're going to do is we're going to get the log to the base 10 of 4.24. So this is read as log 4.24 to the base 10. And using a calculator, we can get this answer. And because the question has specified that they want the answer to 3 significant figures, this is going to give us the answer of 0.627, correct to 3 significant figures. So I'm going to say to 3 SF there. Let's also have a look at the second example given here. It says, solve the equation log x to the base 10 is equals to negative 0.2. In this case, what we're going to do is we're going to convert this into an exponent form. So I can say 10 to the power of negative 0.2 should give me my answer, that's x. And I can use a calculator to work what this is. So 10 to the power of negative 0.2. This is 0.631, correct to 3 significant figures. So x is equals to 0.631 to 3 significant figures. There we go. Just like we have different power laws, we also have different laws for logarithms. So if we look at this here, the log a to the base a would always be 1. Why is this the case? Because a raised to the power of 1 would always just be a. So anything to the power of 1 would always be that number itself. So log a to the base a would always also be just 1. If you had log 1 to the base a, and it doesn't matter what this base is, the log 1 to the base of anything would always be 0. And this is for the fact that any number to the power 0 is always going to give us 1. So log 1 to the base a would give us 0. We also have the third logarithm law, which is saying that log a to the power x to the base a is going to be just x, because we know that if we have a that's raised to the power of x, then the power that we need to raise a by to get a to the power of x would just be x. Then finally, a raised to the power of log x to the base of a would be a. Let's look at this example over here. If we are given the base 4 that's raised to the power of 3, or in other words, 4 cubed is equal to 64, and you want to rewrite this in terms of logarithms, then you can say the log 64 to the base of 4 is equal to 3, or log 4 to the power 3, which is just changing 64 into powers of 4. So log 4 to the power of 3 to the base 4 is also equals to 3. Let's look at some examples of simplification using our logarithm rules. So in the first question, it says simplify log square root of x cubed to the base x. The first thing we're going to do here is, because we know the square root is also raising something to the power of half, I can convert this into exponent form. I can convert this into power form. So this is saying x cubed, that's multiplied by the power of half. And I can say this should be x to the power 3 over 2. So if I rewrite this, I can say log x to the power 3 over 2 to the base x. What's the answer for this? Because of our log law, we know that log a to the power x, that's to the base a, is also going to be x. And in this case, our answer should be just 3 over 2. There we go. So to solve this, that's log 1024 to the base 1/2. Let's go ahead and use our calculators here. So the log of 1024 to the base, I'm just going to say 0.5 here. And using my calculator, you can get the answer as -10. So there we go. The laws of logarithm, we can also use them to rearrange or simplify expressions involving more than just one logarithm. And we have 3 separate laws that we're going to be looking at. The first is our multiplication law, which states that if we add up 2 different logarithms that have the same base, then this is also the same as taking the product of both those values to the same base. So I can say log x to the base a plus log y to the base a is also equals to the log xy to the base a. The division law is telling us that if I have 2 different logs to the same base and I'm subtracting them, then this is also going to be equals to the logs that have been divided to the same base. So log x to the base a, take away log y to the base a, then this is also the same as taking the log of x divided by y to the base of a. And finally, we have our power law. The power law states that if I have the logarithm x to the power k, that's to the base of a, then I can take this power and I can move it in front of the logarithm, and this is going to be the same thing. So this can be converted to k log x to the base of a. While the direct proof of the logarithmic laws are not really important for us at this level, we'll go ahead and see in depth about a little bit more examples on the different laws that we've just learned. So to begin with the multiplication law, we know that the log xy to the base a can also be written in the form of log x to the base a plus log y to the base a. So let's replace these with different values. I can say the log of 32 times 8 to the base 2 can also be written as log 32 to the base 2 plus log 8 to the base 2 because of my multiplication law. Then moving on to my division law, I can say if I have log 32 over 8 to the base 2, I can also rewrite this as being log 32 to the base 2, take away log 8 to the base 2. And finally, for my power rule, we know that log x to the power m to the base a can also be written as m log x to the base a. So let's look at an example here. Say I have log 8 to the power 7, that's to the base of 2. Then I can bring this power in front of this entire expression and I can say 7 log 8 to the base 2 is the exact same as this expression I have on top here. Let's look at this example here. It says if x is equals to the log of a and y is equals to the log of b and z is equals to the log of c, express the log of ab squared over c in terms of x, y, and z. And if you've noticed, you might have seen that there's no bases that have been defined here. And if they have not defined a base, then we're going to say that the base here should be the base of 10. So this means that x is equals to the log a to the base of 10, y is equals to the log of b to the base of 10, and c is equals to the log of c to the base of 10. Now let's go ahead and rewrite this to make a, b, and c the subject of our formulas. So what I can rewrite this as would be 10 to the power x should be a, 10 to the power y should be b, and 10 to the power c should be c. Now let's substitute these values of a, b, and c into the expression that they've given us. So they've said log ab squared over c, and I'm going to substitute the values that I have here. That's all of them to the powers of 10. So the log a is 10 to the power x times b squared. If I work out what b squared is here, we can see that this should be 10 to the power 2y. So that's what I'm going to substitute here. So 10 to the power x times 10 to the power 2y divided by 10 to the power c. And that's what we're going to get. Now, because we know our power laws, we know that when we multiply different values with the same base but different powers, then we can just go ahead and add these powers together. So 10 to the power x times 10 to the power 2y will give me the value 10 to the power x plus 2y over 10 to the power z. Then again, using my laws, we know that when we divide something, then what this really means is that if their bases are the same, then we can just subtract this power. So this would be equals to the log 10 to the power x plus 2y minus c. There we go. Now, we've gotten this. And what I'm going to do is, I know that the base of this, because it's not defined, like I mentioned before, should be equals to 10. And once we've written this, I can see this is a log 10 to the power x plus 2y minus z to the base of 10. And using our logarithms power rule, I can take this power and put it right at the front of my logarithm. So this is x plus 2y minus z log 10 to the base of 10. And what is log 10 to the base of 10? This thing is going to be 1. So I just end up with x plus 2y minus z times 1, which is just going to be this x plus 2y minus z, and that's our answer. So there we go. That's today's lesson on logarithms. Thank you.